My case study is going to be about understanding the advantages and disadvantages of graph databases and brief study of use of graph data structure in graph database. My name is Mridula. So what exactly is a graph database? A graph database is a NoSQL database which is used for exploring correlation within complexly interconnected entities. The structure addresses the limitations found in relation databases by putting a greater weight on data relationship. A graph database is a database which uses graph data structure. When there are relationships that you want to analyze, graph databases become a very nice fit because of the data structure. Graph databases are very fast for associative data sets. They map more directly to object-oriented features like parent-child relationships. They do not have a common query language like any NoSQL database. Some of the most common database languages are SparkQL, AQL, Gremlin, Cypher, etc. This is a base or a database which is based on graph theory. It consists of a set of objects which can be a node or an edge. An example is Facebook, which is a network of people and their activities. So what is the data structure which is used in graph database? It's nothing but the graph. A graph is a structure which contains vertices or nodes, and each of the related pairs of vertices is called an edge. Nodes represent the elements that create the network. They are the users. Edges are the connection between the nodes. They represent the connection between two users. Nodes represent the entities or instances such as people, businesses, accounts, or any other item to be tracked. They are roughly the equivalent of a record, relation, or row in a relational database, or a document in a document store database. Edges are also termed as graphs or relationships, are the lines that connect nodes to other nodes. They represent the relationship between them. Meaningful patterns emerge when examining the connections and interconnections of nodes, properties, and edges. Edges can be either directed or undirected. Some of the bottlenecks of graph-based database and graph data structure are as follows. Graphs, they use a lot of pointers which can be very complex to handle, and they have a large memory complexity. If the graph is represented with an adjacency matrix, then it does not allow parallel edges and multiplication of the graph is very difficult. It is not suitable for network partitioning. Some of the bottlenecks for graph databases are that as it's a very new area, there's a lot of research happening in this area and online analytical processing for graph databases is not very well developed. It lacks scalability and they do not have a uniform query language. The data structure which can be used instead of graphs in some of the special cases could be trees. A tree is a finite collection of data items which is usually termed as nodes. It is used to show a hierarchical data structure between the various data elements and organizes the data into branches which relate the information. The addition of a new edge in a tree results in a formation of a loop or a circuit. Now, when can we use trees? When we want to represent hierarchical relationships like organizational structure, files, like HTML or XML data, we have B plus trees which are used to implement indexing in databases. The comparative analysis between a graph and a tree is as follows. A graph is a nonlinear data structure, whereas a tree is also a nonlinear data structure. Graph can be directed or undirected, whereas the tree is always directed. In the graph, there is no unique node, which is known as root node. However, in the tree, we have a unique node, which is known as root. Graphs can form cycles, whereas trees cannot form a cycle. Thank you.